Okay, let's get started. I just made my way across campus from CS50, and I just finished telling the freshmen there how much you're all enjoying my HCI class. Did I tell them the truth? Everything going all right? Okay, all right. So let's talk logistics for a little bit before getting back to lecture content. You hopefully are working your way through deliverable 3. I think some of you may still be struggling with deliverable 2, and I have now seen firsthand some of the issues that you're having with with timing. So Kai and I sort of figured this out 2 days ago. If you're finding that you have to slow down the iteration in your infinite loop, you need to slow things down, and there's different ways to do it. There is a Leap package called time. And time has a function associated with it called sleep that will put the computer to sleep for however many seconds. If you need to slow things down and you're trying to do real-time 3D graphics, the question then comes up as to where to slow things down. And it makes sense if you think about it. And again, remember that in the innermost loop, you're drawing the 5 times 4 bones in the hand. You're drawing 20 lines. After you finish drawing all 20 lines and calling the, oh, I'm sorry, I've got this wrong. We should have the draw up here. After you've added all the lines to the figure and you've come out of those inner loops that have iterated 20 times, 5 times over each of the 4 bones, then you call the draw, which will take the 20 lines and push it to the screen, then sleep for a little bit so that the user can see it. Then, when the sleep finishes, erase all the lines, come around to the top of the loop again, grab whatever data you need from leap motion as quickly as possible. If you do that, you might still see the lag, obviously, because we're not doing everything quite in real time. But for the vast majority of time, the stuff that's on the screen is the 20 lines. So if you're still struggling with timing issues, hopefully this will help you out. Any questions about deliverable 2? How about deliverable 3? As I mentioned last time, this one's a bit of a monster, so hopefully you've started in on this. There may be a lot of new concepts to some of you, object-oriented programming. We introduced NumPy, matrix manipulation, saving and loading. All good so far? Okay, so back to lecture, and just again to talk about the schedule. As I mentioned last time, I will be away all next week. So next Monday, Jeff Springer will be here on Monday and Wednesday. I'm doing some alpha testing with you on Zemo, the robotics educational game. However, the deliverables will still continue in my absence, so deliverable 3 is still due Monday night, and deliverable 4, I'll try and make this available shortly. And since I won't be here on Monday, we will talk about deliverable 4 on Friday. So we'll talk about deliverable 4 on Friday, but it's not due until the following Monday. Sound good? Okay. I think that's it. So let's see. We were talking about design and how design applies specifically to HCI. So we're still working our way through lecture 4. If I can find it. Here we go. Lecture 4, we've been talking about design philosophy, design process, and design principles. Right? So design process, how do we take an identified need and turn it into an interactive system? So it's a translation. Philosophy, which processes of which different ways of translating need into product are better than others. And then finally, we're talking about design principles. So certain rules of thumb that you're using as you're carrying out this translation from need to product. We've been looking at different design philosophies in different domains of human endeavor, starting with some of the most subjective and the most aesthetic, like fine art, and marching our way towards things that combine technical systems with aesthetics. We talked about fine art last time, visual design, which we'll come back to, Less is more, obviously a very, very important principle whenever you're thinking about what you're going to present to your user. We briefly talked about architecture, because architecture is a nice example of another domain completely different from HCI that also tries to balance aesthetics with hard constraints, right? There's certain things that just have to be in place. Given those constraints, what sorts of opportunities are available? We ended last time by moving into just engineering in general, and one of the most important design principles in engineering and computer science is modularization. Right? So taking whatever the final function of the product is going to be and trying to break it down into different sub-functions, and then thinking about each one of those sub-functions and thinking about, in the case of a physical object, what's the part that's going to support that function? Or if we're talking about code, what's the part of the code that's going to support that function? But have we identified these independent functions? Okay. So now finally we move into software design or software engineering. Like engineering, we want to do our packed analysis and draw out of all our P's and A's and C's, hopefully a very specific set of functional requirements. The system should do this, it shouldn't do this. When it detects high light levels, it does this. When it detects small hands, it does that, and so on and so forth. Right? So a big part of design is taking all of that exploration we've done with our target demographic and turning it into requirements that our software engineers, who may not have ever talked to one of the users, can start to try and turn into software. A big design principle, a good rule of thumb to follow in software engineering is iterate quickly, as often and quickly as possible. I think I ended with that last time, and I'm feeling brave today, so let's do a live demo. I've seen that a lot of you code Python in various IDEs. I'm very old-fashioned. I used Vim, which I like because it sort of strips away a lot of the complexity. Let's imagine that I want to write some Python code that adds two numbers together. Not a very sophisticated piece of code, but I'm going to try and iterate as tightly and quickly as possible. So I'm going to code, and I'm not going to talk while I code. What I want you to watch me doing is trying to add the smallest piece of code I can, and then running it. And the moment between me adding a line to the code and then running it, I want you to form a mental model or make a prediction about what you're going to see on the screen. Did the line that I added change the functionality at all? Yes or no? If it did, what do you expect to see when I run the code? Right? Most good coders get practice and try and tighten this loop as quickly as possible. And as they're doing it, they're always making predictions about what the code should do. And if it does, then back they go and debug it. Right? It's easy to get lazy as a coder and just add some stuff and run it and just sort of see what happens. But if you just sort of see what happens, how do you know whether it's working well or not? And if it doesn't do what you expected it to do, again, if you make a prediction and your expectation is frustrated, why? Where are you going to go back in and find the problem? If we add as small a piece as possible, we can usually be pretty clear about what broke the code or what changed the functionality. Okay, here we go. Okay, add.py. Okay. So again, not a very sophisticated piece of code, but doing this very quickly and making predictions about what I should see. Okay, just the design principle, and again, depending on your design philosophy, you may either agree with this design principle or not. Is this a good process towards creating scalable or very complex code? Just an example of a design principle. A design process, which used to be very popular in software engineering, somewhat less so, is the design process known as the waterfall method. In the old days, the idea was to spend as much time as possible talking to the users, figuring everything out, boiling this down to a clear set of requirements. And all of those requirements together was known as the specs, right, or the specifications of what the system should do. Design the system architecture. So don't write any code yet. Take those requirements and start to write boxes which might correspond to object instances or different parts of the code, and then arrows that indicate how those pieces work together. It might be a finite state machine for those of you that have heard about that concept. So basically figuring out a system that should instantiate those specifications and analyzing that design to see whether it actually does. And only then, if you've made a very, very careful design, you should be able to take that design and translate it almost one-to-one into code. So in the waterfall process model, there is a resistance to starting to write code early. Wait until you've figured out exactly what the code should be doing and what it shouldn't be doing. Figure all that out, then write it, debug it, deploy it to the public. Okay. Works well in certain situations where the specifications don't change too much. If you can get your users to describe exactly what the software should do, for whom and when and where, that's great, right? Usually you have a pretty good set of specifications. If any of you have actually worked for a software production house, you know that in practice it doesn't usually work that way, right? Usually we get halfway through writing the code and the users say, well, oh, wait a second, yeah, actually what I meant to say was, or, oh, right, I didn't realize that the software should also, and so on and so forth, right? Remember the brainstorming session we did about Leap Motion, right? So you start writing your educational software for Leap Motion, and then someone says, I waved my hand in front of it and it didn't work, right? Without your code, just Leap Motion in general, and you realize, wait a second, that person is waving with their left hand. We didn't think about that. Back we go, right? So we don't usually have the luxury in HCI of talking to our users, boiling it down to specs, designing, implementing, debugging, and then finally deploying. So most HCI design processes look much more like this. I think the book has a different diagram, but the basic idea is always the same. User testing is front and center, right? So there isn't a real linear process here, which is nice because whatever we're doing, trying to write some requirements, create a simple prototype, and showing it to the users, that's great because it's kind of fluid, right? We can continuously change the specs and prototyping as we go. It has the drawback, however, of being a never-ending process, right? The nice thing about the waterfall method is once you get to the end, you have a perfect version of version 1.0 that's out there, and you're good, right? If new specs come in for version 2.0, that's fine, but at least you know there's a beginning and an end. Where is that in HCI design, right? And this obviously matters if you're doing this in practice where there are time and financial constraints. Okay, so in a couple lectures, we're going to unpack each one of these boxes. Prototyping is pretty obvious. Envisionment means sort of trying to create some visual representation of what this thing is going to do, right? So you might take a piece of paper and draw what your user interface is going to look like for your ASL educational software, right? What are all the different ways that you might actually create simple prototypes and allow the user to envision what the final system will look like? Right? Sure. It's not uncommon with hardware design these days to make a cardboard prototype, right? Something you just hold in your hand and there's fake buttons drawn on it and so on. 3D printing helps a lot with that. We've already talked quite a bit about requirements. In HCI design, you hear a lot about conceptual design. So conceptual design is basically another word for pact analysis. So sort of thinking about the system conceptually, who's going to use it, what, and where. And the physical design, in my opinion, it's not that different from prototyping, right? Making the actual hardware. Okay. So just to flip back and forth, I'll come back to the slide in a moment. We can sort of sum up software engineering design, which is creating this set of functional requirements. What are the functions, plural, that the system should do? HCI has obviously the same goals. Your software has to instantiate a number of functional requirements. The system should and should not do that. But in addition, your software is also trying to meet an additional set of requirements, which are often called non-functional requirements, which is not the best term. But it basically means forget about the basic functionality for a moment. What are the global properties that the system should have? Right? Can we actually specify the accessibility, the usability, the acceptability, and the engaging properties of this system? So one way to think about this is when you're developing your HCI system, it instantiates a bunch of functional requirements. It has 12 different functions. But all of those functions together, when the user sits in front of the system and uses it, there's this user experience. Some of you might have heard UX, which is related to HCI, the user experience. Right? They may not be aware that they're using function 3. If you ask them about it, they say, well, I used it, but it didn't allow me to do what I wanted to do in the best way. It was forcing me to do what I needed to do in a way I didn't want to do it. Right? That's sort of something to do with the global experience or the global properties of your system. So the biggest challenge in HCI is identifying these global non-functional requirements and being able to write down specifically how your software is going to meet these non-functional requirements. So in the rest of lecture 4, we're going to look at these non-functional requirements. Let's start with, again, as we've done several times now in this course, let's start with some of the more obvious ones. So is your software or is your interactive system accessible? Is it accessible to whom, right? So there may be certain aspects of your system that exclude other users. So instead of thinking about accessibility, if we're going to try and make our system accessible, but we want to write down some specific requirements to support that property, it's usually better to invert it and think about exclusion, right? So our system will not exclude lefties and people with small hands and so on because, and now you introduce a functional requirement, we're going to flip all the 3D coordinates around the x-axis. That will ensure that we don't exclude or we include lefties and righties equally, right? So we're going from sort of this general thing down to very specific requirements that can be pretty easily turned into code. Okay, again, physical exclusion is pretty obvious. We've already seen lots of examples of this. Conceptual exclusion, right? This is again a little bit trickier. Are people being excluded because they can't grasp the cause and effect that's going on in the system, right? A good example of this is usually software doesn't say much about double clicks and single clicks. Most people kind of figure this out. But it can be hard for some people to wrap their minds around where's the boundary, where's the temporal boundary between two single clicks, one after the other, and a double click, right? In your system, where is the invisible boundary between where the Leap Motion device sees your hand and not, right? Most of the visualizations you've seen for Leap Motion make it pretty clear. You can figure out where that boundary is, and you can start to make predictions. If you watch yourself or you watch somebody else who's gotten pretty good at Leap Motion, you'll see them keeping their hands within this box, right? They built up a mental model of where this box is. Is the software you're making going to make it easy for someone to figure out where that box is or where the conceptual boundaries are in your system? Economic exclusion, that one's pretty straightforward. Cultural exclusion, this one is, again, a tricky one. People make predictions based on their experiences with the physical world, but also the social world. So people from different cultures have different predictions about or expectations about certain things. We've talked in this class about visual analogies. So you maybe don't want to write a whole bunch of text to the screen because maybe some of your users are not going to be native English speakers, right? Can you communicate a lot of your system without writing actual or having pop-up bubbles that actually explain things? Can they figure it out based on what's going on the screen? So just as an example of cultural exclusion, I think Kelly actually mentioned this example a few classes back. This is the Sugar interface, which was the software, the operating system that ran on the One Laptop Per Child project. So this was a project a few years back about trying to create an extremely stripped down laptop that could be given out to young people in developing countries. This was more or less pre-cell phones. Cell phones have kind of made this irrelevant. But anyways, it's a good example. Here's an example of the Sugar interface, which hopefully has no English text on it except up here. Right? Again, most of the target demographic for the Sugar interface were assumed not to be native English speakers. Here, imagine you are a young person or a young child, let's say about 10 years old, in a South American country. You live in a small, very rural village. Let's say you have access to YouTube on your parents' laptop or phone, so you've seen stuff from the West, and you're presented with your own computer, and this is the interface. Some of these visual analogies maybe make sense. What might this suggest to you? Maybe it doesn't.
Just connect to other people as a group.
Connect to other people, yes. So other people, that's pretty clear.
Like a dense population in that area?
Yes, why? So there's
a whole bunch of people in one little group.
They're around something, right? This is a visual analogy. Obviously lots of people, they're around something. What are they around? I have no idea, right? It's not very clear. I can't figure it out. I've been presenting this slide for quite a while. We can see that these are other people. Is this a map? Are they actually in these positions? Is this something like Google Maps? So I've seen Google Maps on my parents' phone. Is that what I'm looking at? Where are these people? Where am I on this map? Are these people near me? Are they in my village? Are they near me on the internet? I kind of know what the internet is. Are they near me? Here's some icons, and it turns out that I found out that I can click on these. What does this one mean? If you're a 10-year-old from a rural village in South America. What's that?
Draw something.
Draw something. How did you know that?
The palette.
Yes. How do you know what a palette is?
We've been seeing it as an icon for a while.
You have.
Yeah.
Maybe they have, depending on how much internet exposure they've had, right? This is a paintbrush on an easel from Michelangelo, or it says something like that. Maybe it's obvious. Okay. What about this one?
Tic-tac-toe.
Tic-tac-toe. Maybe you have a game, or you've seen tic-tac-toe, or you know about checkers and chess. Maybe you can figure this one out. That this is where the games are on my machine. Okay, that's good. This is my favorite one. This is the one Kelly mentioned. What does this suggest? All right. It's supposed to mean go there, right? That if you want Wi-Fi, that's where you should go. I would imagine that if you're in a particular South American country that has volcanoes, you are very unlikely to want to go to there. You might go warn your friends that are right here that they should get the hell away from whatever this thing is, right? These were HCI designers that knew they were making an interface that was going to be used by young people in rural villages in developing countries, and this is what they chose to try and advertise Wi-Fi, right? It's, again, obvious to laugh at in retrospect that it's probably not the best choice, but it's tricky to get it right. If you're trying to advertise without writing it in text about where Wi-Fi might be near your village, near your rural village, what picture would you draw? Right? You need to put yourself in the minds of the person you're trying to design this interface for. It's obvious there's lots of examples of where this is not done well, not easy to get it right. Okay, so that's the idea of cultural exclusion, right? Certain people that don't know that this means Wi-Fi are going to have a hard time using this system. Finally, social exclusion, right? We've talked about that one already. Are people using it at the same time? Is there something about social dynamics that will make it harder for certain people to use something? Okay, so we want to try and take this accessibility, turn it around into exclusion. Are we excluding anybody by these particular requirements, right? Wi-Fi will be advertised using this visual analogy. We can start to write things down and think about, are we excluding anyone? Are we making our system usable, right? So there's always this temptation in HCI, and you're going to do some user testing later in this semester, that you test it out on your flatmate or a friend or whatever, and they say, yeah, it was great. I like using it. And you come back and say, yeah, my system is usable. What exactly does that mean? The person who's paying for you to develop this interactive system might say, yeah, I want it to do this and I want it to be really usable. What exactly does that mean? It's hard to take usable and turn it into requirements. Okay. The book is great because, again, it basically seems to go in circles. So it defines a usable system as easy to use, easy to learn, flexible, and engenders a good attitude in people. These all seem like equally vague terms to me. So let's see if we can try and sharpen what we mean by usability. Well, there's certain things that are a little bit more specific. So efficient, right? So somebody sits down in front of your system, or they use your system and a competing system, and they time it. How long does it take them to do the activity in your system and the other one, right? There's something that's very measurable that you could turn into a requirement. Our system will be efficient if user X can carry out function Y in 3 or fewer steps. There's a requirement that we could build into our system. Okay. Effective, so is everything sort of organized? Can they actually do what they want to do? Maybe it's not 100% effective. They can get 90% of what they want done and the remaining 10% somewhere else. They export something from your system, take it to another system, and finish the job. Does your system fully support the whole activity? Do you know what that activity is? Is your system easy to learn and easy to remember when you come back to it later? So now we're getting back into the psychology part of HCI. What makes something learnable and what makes something memorable? These are not necessarily the same things.
Lower cognitive load, so when you're looking at something, you're not having to think too hard about it.
Okay, when you're looking at something, you don't have to think too hard.
Like, it's easily recognizable to you, and you're not having to memorize exactly what it is every single time.
Okay, so we're going to talk about that in a minute, right? Recognition over recall, right? So it's easy to learn something if most things, once you see them, yeah, I remember, I recognize that, I know what it is, I don't need to memorize it, right? If I have to memorize a bunch of things, it's not going to be very learnable. It's going to take a while. What makes something memorable? So you come back and you need to use it. Simple. Okay, simple how? So again, in HCI, we're always trying to sharpen these vague terms down into something that we can turn into requirements.
Like something that's similar to what you do in like everyday life. Something that would kind of remind you, like, I don't really know how to explain it, but like something that you do in everyday life that would affect the system in the way that you kind of expect it to.
Absolutely, right? We kind of talked about that already. And this also comes back to recognizable, right? So I haven't used the system for a month. I turn it back on and there's a little arrow. Oh yeah, there's a cursor. I need to move the cursor. Or there's a blinking vertical line. I need to type something in, right? All those sorts of things suggest how it should be used. Are there any Linux people here? Linux is notoriously, it takes a little while to learn, and most of the commands in Linux are extremely cryptic. Why? That seems to be going against this idea of making something easy to learn and memorable. It's a huge Linux community out there, right? Why? Why would you want to make something that's not easy to learn or easy to remember?
Because you get greater functionality when you strip away a lot of the GUI, or well, the UI, I guess you could say.
You strip away the GUI, everything's done at the command line. You just saw me doing something at the command line, right? A lot of that is non-intuitive stuff. It takes a while to learn all the commands in VI, for example. So it provides more functionality, but in what sense? What do we mean by functionality here?
Well, that just kind of comes like a byproduct of having a necessarily what other people think is best.
Okay, that's right. So that's an aspect of the Linux community, that it's open, right? But that's kind of orthogonal to our current discussion about the crypticness, I don't know if that's a word, of Linux, right? If you want to list the files in your directory, you don't type list, you type ls, right? You've got to remember that. It'd be easier if it was just English words, right? It'd be easy to remember when you come back.
Perhaps so that it works across language communities, that it's not precisely.
It's equally cryptic for everyone.
Right.
Maybe it's leveling the playing field. I don't think that was the initial intent.
I don't know what you're going for, but I think of Linux as like if you have an advanced options menu on something, you're basically allowing, customization of something like they were saying before.
Okay.
You just have a lot more options as far as how you want to use that application, as opposed to like Windows or Apple where they're distilling all that information. It's a lot harder to really get into like the nitty-gritty processes of the actual program.
Okay, so Linux is much more customizable. It's open, comes back to all that. But again, still not so much about why ls rather than list. I think we're kind of overthinking this.
Like obviously to reduce the footprint of the code.
Reduce the footprint of the code.
The code, but like
You're getting close. Reduce the footprint of what?
Efficiency.
What's that?
Efficiency.
Efficiency, right? There it is, right there, number one. So efficiency. Takes 2 keystrokes, 3 keystrokes, ls, enter, to list files rather than 5, right? Doesn't seem like a lot, but if you do use Linux, think about how many times you've typed ls, right? Thinking about the users. So even little things like that can have a huge benefit, right? Linux, once you know how to operate a Linux machine, you can be extremely efficient. So if you're not a Linux person, sit down next to a Linux person and challenge them to a race to do something, right? It's amazingly how quickly you can do things. So a lot of the usability factors or a lot of non-functional requirements in HCI have a bit of an antagonism, right? So making something more efficient often makes it harder to learn, right? And vice versa. That's fine if that trade-off is there. Know that trade-off is there. Make that trade-off clear to your users somehow. So new users can say, okay, I realize there's a trade-off. It's going to take me a while to do this. I'm going to learn this, but now I want to become more efficient. How do I do that? How do I start to delve into the more cryptic and more efficient side of things? Okay. Safe to operate, we already talked about this. We saw the example of the FAIR Act 25. Again, thinking about the actual system and how it's going to be used, there are often non-obvious safety concerns that have to do with the fact that that interactive system is being used out there in the real world by a diversity of people. Can you think of examples of software that became unsafe once it was being used by lots of different people in contexts for which the system was not originally designed?
Pokemon Go.
Pokemon Go, perfect example. What's so dangerous about Pokemon Go?
Well, people are staring at their phones while they walk out in front of traffic.
Exactly, right? Maybe Pokemon Go designers thought about that. I think the opening screen now has this huge red exclamation point, right? Look up. Okay, great example. Utility, last one here. This one's a little bit tricky. So this one is, a system has high utility if it allows someone to carry out the task in the way they want to do it. So how does somebody want to get something done, right? It might be that your system is very cryptic and it's exceedingly efficient, but it's not the way I want to do it. I like to do my taxes every year in 1,000 simple steps, where every step just asks me a question about yes or no. I like the fact that there are a lot of simple steps and there's just yes, no. I love that much more than the much more efficient form, which is much more difficult to fill out, right? What is the way in which I want to do my taxes every year? And once you know how I want to do it, now you can start to think about the software to support that task. Lots of different people like to fill out their taxes online in different ways. How should we support that? Right? We can create software that allows someone to do their taxes, but not in the way they want to do it. Okay. How do we actually ensure these 5 aspects of usability? As we saw in the HCI design process, we usually need to go back to the users over and over and over again. So early focus on users and tasks. Who is doing what? We've already talked about this one. We haven't really talked about measurement yet. We're going to get into that a fair bit in the next part of the course. If you have written requirements for these 5 things and you deploy a prototype to the users, what do you measure to determine whether your system is efficient or not, whether it's effective or not, learnable or not, safe or not, has high utility or not? Let's start with efficiency. What do you measure?
Speed.
Speed, right? So you've got a stopwatch somewhere. What else? What other measurements might you bring to bear on efficiency? Yep. Accuracy, okay. Number of keystrokes. Imagine lots of different things. Yep.
And generally, like whether completing the task requires a lot of repetition.
Repetition, that's a great one, right? So I think we have this on the next one. If a system is unsafe or sort of too open-ended and people are going back and fixing mistakes that they've made, I mean, maybe that's fine. It depends on what you're doing. But should you allow so many mistakes? How do you know? Can you actually record how someone is flowing from the beginning to the end of the task in your system? You're going to see this a lot with Leap Motion. Right? You've probably seen that Leap Motion isn't perfect, and sometimes you have to kind of shake your hand or pull it out of the screen and put it back. Right? How is your software going to deal with those kinds of, not mistakes maybe, but repetitions or going back a little bit and then going forward again? Okay. How would you measure how learnable or memorable your system is?
Like rate of error as far as clicking on something. I guess, yeah, if that makes any sense.
Sure. So if you can't remember something or it's not very learnable, you're going to make lots of mistakes. But again, we want to try and sharpen things even further. What mistakes are we looking for? So we can measure the number of mistakes in general. If we want to try and measure how memorable our system is, what might you measure?
We'll have someone use it, and then after a period of time, have them use it again and see if they can, their efficiency improves, if they can go through whatever program quicker and easier without making mistakes.
Exactly. So have the user come back. Come back an hour later, a day later, a week later. How many times should they come back? When they come back, what are we going to measure? User testing is not an easy thing to figure out, right? It would be great if you could test your system on 1,000 people and every person is going to test 100 versions of your software over time. You're probably going to have a limited testing budget. How are you going to make best use of your users for testing, right? We do want them to forget for a little bit and come back and then measure the number of mistakes they make when they come back, or how often do they refer to help pages or whatever. Okay, so a lot of empirical measurement, right, and thinking about what to measure when and how. And this idea then about iterative design, which you've already talked about. So a test should not just be a survey. Did you like the software or not? A test is a very rigorous measurement procedure. Then once you measure these things, how do those measurements feed back to the next iteration of the design, right? So your users come back after not seeing your system for a week and they make lots of mistakes. Where in your requirements do you need to make changes? Where in the code do you need to make changes? Again, it's often difficult to take a big stack of data, which are your measurements, and realize where in your system do those measurements point? What should you change to improve those measurements the next time around? Okay. You want to try and make sure that most of these usability factors are optimized together because of these adversities, right? You might improve the learnability of your system, but if you're not also measuring or continuing to measure efficiency, unbeknownst to you, you're seeing during user testing that the system is becoming more and more memorable, but it's also becoming less and less efficient. So your measurements should usually be hitting all of these non-functional requirements together. You're trying to optimize them all together as best you can. You can't do a perfect job because of these antagonisms, and we already talked about some of these antagonisms, so we'll skip over the question at the bottom. Okay. How do we know if something is usable? This is kind of a fun one. If you ask people to talk about your software, they will the way they talk about your system or the user experience often betrays how they feel about it. Most very usable tools, things that are incredibly good at supporting the task, people tend to use verbs rather than nouns. So people usually don't talk about using a hammer, they talk about hammering, right? So the tool itself becomes a verb because the noun and the verb get mixed up. Your software is so good at supporting this activity that the two things become one and the same. By using this thing, I'm actually Xing or Ying or Zing. I'm doing the thing that I want to do, right? Lots of examples of this from technology itself. What are some examples of technologies that have been verbified? Google, right? The most obvious one, right? You got to feel bad for the other search companies, right? No one really talks about searching anymore. Well, some people do. Most people talk about Googling.
Dang it.
Or Bing it, yeah, there you go, right? Haven't heard that one in a while, right? It's amazing when you stop to think about it, right? How many times a day do you search for something on the internet, and when you talk about it, you don't use the very old English word search, you talk about Googling it, right? What a triumph for this company. Other examples of verbification.
Doesn't like every social media have one now? Like,
Well, they
some
learned-
people say Facebooking and tweeting.
They learned from Google's example, right? To tweet or to Facebook.
Just texting, because that wasn't even a word back in like early 2000s.
Texting, right? Exactly. So there's a lot. If you look at the new entries per year into the Oxford English Dictionary, there's a greater ratio of verbs to nouns, right? It's kind of interesting. The language itself is changing because there are all these new technologies that are so good at letting you do what you want to do that you don't talk about using Google or using Twitter, you tweet or you Google, right? Kind of an interesting principle. When it goes wrong, when you mash your thumb with a hammer, now you become aware of the object itself, right? So if your users are talking about, I have to use their software, right? That's usually a sign. If they start verbifying your educational software, you're in good shape, right? So again, taking cues from your users about, they may be able to tell you explicitly what's good and what's bad about your system. You may be able to measure things from their interaction, but also just listening. Okay. Is your system acceptable? This is, again, a pretty good one, an interesting one in HCI because this one is slippery, hard to nail down. You might have a prototype of your system and you bring your users into the testing lab. Everything works great. You deploy version 1.0 and people go out there in the world and start using it, and the system is absolutely terrible. So acceptability is like usability in the field. Where and when it's actually going to be used, is it acceptable, right? So usability is easier because you can usually test this in the lab. Accessibility is something that you can only really test once you've deployed your system into the field. Okay. Examples of systems that are very usable but not so acceptable. Things that work great for one person sitting in a laptop in a room, but not so great when that software is running out in the wild. Yep.
Google Glass.
Google Glass, why? Extremely usable, not very acceptable.
Yeah, it became seen as like kind of like something that was used regular and uncool after the amount of time.
Perhaps, yes, it's also a fashion statement, right?
Yeah.
Extremely useful. You look at the camera and where you're looking, how your eye is saccading is being recognized by Google Glass. So just by moving your eyes, you're accessing the internet or taking a picture or whatever it is that you're doing. They got that part right. Extremely usable, efficient, effective, obvious, recognizable, not acceptable at all. Our society is not ready to accept people wearing glasses that may or may not be taking pictures of you, right? Maybe someday it will be, but at least for the present time, not yet. I'm an Android user on my phone. I don't know if it's the same on your Android phones. When you plug it in and it starts charging the battery, when the battery gets to 100%, it just gives a little beep to say that the battery is fully charged. I've been looking through help pages for weeks about how to turn this off. I can't turn it off. If anyone knows how, that would be great. It's a nice feature. For me, it is absolutely unacceptable. You can probably guess why from the course of this story.
It's the middle of the night.
Middle of the night. So I go to bed, I plug in my phone. It's usually at about 80%. I tend to use about 20% of my juice throughout the day. That 20% takes about the same amount of time it takes me to just being on the brink of falling asleep without fail every night. It's like they tried to maximize the unacceptability of that particular function.
Probably under settings, sounds, other sounds.
Famous last words. All right, I will try that. Say that one more time. Settings.
Settings, sounds, other sounds.
Setting sounds, other sounds. I will try that after lecture today. Okay, right? So that's a hard one to test, right? Unless you give the software to people and they're plugging it in and falling asleep next to their phone and so on, right? My story is one of millions like that about acceptability. Hard to test and measure or anticipate a priori. Okay. I think this one's pretty straightforward. What makes up acceptability? Are there political issues? So I think UVM forces particular software on you. They also force particular software on faculty. Most of that software is pretty unacceptable, or it's less acceptable because it was forced on us rather than we were given the choice. You might be more willing to accept the software that UVM makes available to you if it wasn't forced upon you, right? So unbeknownst to the software designers, there may be political dynamics going on among the group that's targeted for using the software, right? Convenience, this one's kind of related to usability. Can I charge my phone when I want? So because of this unacceptable feature, maybe I need to charge my phone at the office, but that's just not how I like to do it. Now I have to have my cord at the office. What happens if I'm traveling? So on and so forth. Okay. Cultural and social habits, right? This one's pretty important. And again, economic factors. Ebooks have finally kind of made it into the mainstream. It took a long time to get there. They were pretty usable for quite a while, but not so acceptable. Why? What made ebooks kind of unacceptable for quite a while?
It was difficult to read in the sun initially.
Exactly, all right. And that one was kind of anticipated, right? People are going to be reading in the sun. So that one was kind of folded back into usability. They made lab settings with sunlight or put people next to a window. What are some less obvious ones that cropped up?
Well, illegal sharing of ebooks.
Okay, illegal sharing. Okay, that's right, but not so much about the acceptability, right? We're talking about the actual activity of reading, right? That's the activity that ebooks are supposed to support. Tricky for an ebook to get this right. What is it that people tend to like to do? Us old-fashioned folks that still like to. What's that? Highlight stuff. Okay, so that's all right. Maybe you want to do that. Flipping pages, right? This one took a long time to get right. There's still quite a few people out there that prefer to actually flip pages. Most people said, okay, I will count this as flipping a page. Most young users don't care, and this is perfectly fine for forward and back, right? But this action, right? This is a big part of reading, or this, right? Or I know it's about 20 pages back, right? I know I need to do about this much to get back to that paragraph I wanted. There are all these subtle actions that are wrapped in the action of at least reading with a physical book that had to be incorporated into early ebooks before it became acceptable. Okay, I think we'll stop there. You have a quiz due tonight, and we'll talk about deliverable 4 on Friday.